In this video, we will explain how Akana policies will help you to protect the content of messages that are exchanged through your APIs. Content can be protected by having it digitally signed and/or encrypted. We will show how JOSE security can be used for this purpose and what policies Akana offers to help you implement JOSE security. Ensuring that data are exchanged in a highly secure manner is a critical aspect of any API architecture. A robust and reliable security implementation involves measures taken on various levels. To start, API endpoints should be secured, and only authorized clients should be allowed to successfully interact with them. Once the connection has been established, validation of the incoming message should be considered as a next step. For example, this could be a requirement to verify authenticity and integrity of the message. Can its origin be trusted? And can we ensure that the data have not been tampered with? For such validation purposes, message signing and, as an additional step, encryption can be used. A predominant standard for the digital protection of API message content is called JOSE security. Essentially, this refers to a set of specifications that allow you to secure data by signing or encrypting them, with the result presented in a JSON data structure. In case of signing, the resulting object is referred to as a JAWS, a JSON web signature. In case of encryption, the resulting object is referred to as a JWE, which stands for JSON Web Encryption. Signing is used to ensure authenticity and integrity of the data. In addition, encryption can be used to also ensure data confidentiality. JOSE security can be applied to both request and response message. In addition, from an exchange topology perspective, it can be applied to the messages exchanged between client applications and API gateway, and to the exchange between API gateway and the target backend system. Akana offers an out-of-the-box configurable JOSE security policy which supports all of the exchange scenarios mentioned before. For example, you can configure the policy to validate the signature that is generated for an incoming request message, which is now presented in the form of a JAWS. Only requests with a valid signature will be accepted. You can also configure it to ensure that the outgoing response is signed. In this latter case, it is the client's responsibility to validate the response signature and decide whether to accept or reject the response. Similarly, you can configure the policy to sign the request as it is sent from API gateway to the target service. In case the backend is returning a signed response, the policy can also be configured to validate the response signature. Only a valid response will be returned to the client. In addition to signing the message content, the policy can also be configured for encryption. For example, it can be configured to decrypt and validate an incoming encrypted request, which in this case is presented as a JWE. The policy can also be configured to encrypt an outgoing response, encrypt the message as it is sent to the backend, or decrypt and validate a response that is received from the backend. As encryption is always using asymmetrical key pairs, it ensures confidentiality of the payload data. The JOSE security policy also supports a special case, which is the way JOSE security is used with UK open banking. This open banking specification requires signing of message payloads. In this case, however, a detached payload scenario is used. The payload is detached from the JAWS object once the signature has been computed, and the remaining elements are put in a special HTTP header. The JOSE security policy can automatically create a JAWS in conformance with this specification and put it in the specified HTTP header. Also, the policy can validate an incoming request which is presented as a JAWS with detached payload. To complete this video, let's show you an example on how to configure the JOSE security policy. To start, log into the Akana developer portal with your business admin credentials. Additional policy instances can be created under an organization. To access the available organizations, click More in the top-level menu. Next, click Organizations. And finally, All Organizations. With this example, we will add the policy to the root organization. Click your root organization. Click Policies in the left navigation menu. and click Add to create a new policy instance. Enter the name in the designated field. Select the applicable policy category. In this case, we select Operational Policy. From the Policy subtype dropdown, select JOSE Security Policy as the policy type. Provide a description for the policy. Click Save to save your initial configuration. Next, we can configure the specific policy settings. On the first options page, check all options for the protection scope field. This indicates that JOSE security will be applied to both the incoming request and to the outgoing response or fault. Select Compact to enforce the use of compact serialization for the JOT objects. Check Provider. This indicates that the policy will apply to the messages that are exchanged between client and API gateway. Click Next to proceed to the next step. On this next configuration page, you can configure the policy settings that apply to the incoming request. To apply message signing, check Signed Content. The policy is now configured to validate the signature of an incoming request. With this example, the client application that sends in the request is responsible for the signing of the message. Select Consumer to configure the policy as such. As we will not configure encryption with this example, click Next to proceed to the next step. This brings us to the page on which to configure settings as they apply to the outgoing response or fault message. First, check Sign Content to ensure that the response is digitally signed. The client determines the algorithm that is used with the request message. However, the algorithm that is used for the outgoing message is determined by the policy. This algorithm will be applied by the API gateway. With this example, we will use an asymmetrical algorithm. For example, select PS256. By default, the Akana platform will use the key store that is configured for the platform. You can also use a user-defined key, which can be configured using a platform identity. Click Next to proceed to the final step. Click on Finish to complete the configuration process. And finally, click Close to exit. Once policy configuration is complete, the policy can be activated. Click the triangular icon in the top-level menu. Choose Activate Policy from the options. Enter some comment. Click on Confirm to finalize policy activation. Your policy is now ready and can be attached to any API that requires JOSE security. In addition to the JOSE security policy, Akana also offers a policy to support more advanced JOSE-based security standards. The policy can be configured by using out-of-the-box available templates. In this video, we presented an overview of JOSE security and how to configure the Akana JOSE security policy to implement the appropriate signing and encryption of message payloads, thereby ensuring authenticity, integrity, and confidentiality of the message data.